Hello everyone, I hope you all are doing well. So, in this session, I'm here with the complete CFD analysis of FSAE car using SolidWorks flow simulation. Here, we will see how to deal with the drag force and finding out the coefficient of drag and dealing with the mesh as well and dealing with all the results using contour float and the cut floats, iso floats, and the flow trajectories. We'll see each and everything in depth. Let's get started with this. Yeah, so if you need to start with the flow simulation, so you need to activate the add-in flow simulation. From there, you can use the wizard tool. Here you can just define the project name. So I'll just name it CD analysis, that is coefficient of drag. Here the velocity I would like to take with respect to kilometers per hour. The analysis type, anyway we are running the external flow analysis. I'll activate the gravity. Gravity should be along y direction, as you could see the coordinates at your left corner. So even you can just see the image and the orientation of the gravity. Here the gaseous fluid, I'll take it as air, and the flow type is laminar and turbulent combined, and humidity I'll take it as default. The wall is adiabatic and the roughness is 0. By default you keep everything same, and here the velocity I need to define. So here I'll take it 100 kilometers per hour for a reference. If you want you can just keep it as per your requirement. So along x direction we have defined it. So these are the initial inputs. So once you define these things, automatically it will create the computational fluid domain. So that might be quite bigger one, so you can even customize it. So let's say if you want to just orient to normal view and just use the drag method, or you can even right click on the computational domain and edit it, and manually can able to enter the values according to the standards. So here I'm just using the push pull method to just define the computational domain according to my need. You can do the same thing. Just to click on computational domain, the domain will get activated to just make the changes. So once you feel this is fine, you can go with the other boundary conditions. So no boundary conditions needed here because we have defined in the input only. So you can hide this at the moment to just avoid the simply graphics. And results, very important, I'm concerned only about the drag force and the lift force, and the coefficient of drag and coefficient of lift, very important things. So along x direction you need to remember it is drag force, along y direction it should be lift force, very important. So it might be confused in some sessions. I even got confused by myself. Yeah, you can rename the goals. So I'll just rename it to drag force, and this should be along y it should be lift. Remember, along x it is drag force, along y it is lift. I'm repeating. Yeah, so once you define these things, the mesh, so by default automatic mesh will be there. You can even set level 7, and you can even add some refinement using advanced channel refinement, but in the manual method you can able to refine your mesh in a better manner. I'll set it to refinement level to 6. The number of cells inside per cell is 5. I'll take it. If you want you can use the refinement levels, but I don't want them. And next thing is the advanced refinement level, so I'll take it level 3. But remember, as you finer your mesh, the time lapse will be the same. You need to keep that one in mind. So this is the global mesh. I'll add the equation goals, very important. So the formula for the CDCL is, you already know that one. If you don't know, that is 2 times of drag force or lift force into rho v square into area. So I need to add the goal. I'll take the drag force, 2 times of drag force, divided by, I need to close this bracket, divided by just add the formula, that is density rho 1.225 into v square. Can add the brackets properly. So this is very important. This is manual. You need to take care of this properly. So 27.78 is the 100 kilometers per hour value into the area, the frontal area. So I don't know the value. I'll take it 10 now. You can edit it later. So as I need to calculate the frontal area, it is quite difficult to consider the exact 100% frontal area for the calculation. So I'll take the rough approximation. So take that rough approximation as well. It is very important, right? So I'll showcase what to do for that. You can just go to SolidWorks evaluate tool, and from there you can use the measure tool. And here you can select the approximate frontal surfaces which are going to contribute for this fluid flow resistance. So I'm going to take these all the faces for references. This is just an approximation consideration. If you have any other alternative methods that you find suitable for this, you can even deal with that method. There is no issues with that. So as I'm concerned with only the approximation results, so I'm taking only these references for my sake, and to save the time I'm just taking these things. Sometimes selection might not work. You just need to align it properly to select the surface. Yep, this is fine, but even the seat and remaining steps also impacts a lot. I'll select these. Even weldment structures might impact. Even though it's a rough approximation, it should be near to perfection, I consider. So even these, can even consider the wheels, the frontal wheels, but you need to split the faces to select that particular area. Okay, that is kind of time consuming, so I'll avoid that. Yeah, can even consider these. Inside I don't need anyway, like due to some the person who is sitting inside hand touch or something, it will take. So it is around, well, you can see, no. So I'll take approximately slightly more than that. Yeah, this is fine. So once you consider this formula, you can take the same formula, you can copy this one at the moment, and you can use it for coefficient of lift value. You just need to change the lift force there, equation code, paste it here, CL. Now here, instead of drag force, I need to just select the lift force. Add goal, select lift force, add. Your formula is fine, the bracket is also fine. Yep, green gel. So this is how we can just define these CDCL things. Yeah, once you're done with this, you can run this. Before that, you can even mesh it properly. So every time we will just run with the default mesh, that is not going to help, and this is how it looks like. Now I'll add some local mesh. This local mesh is related to your part, not the external fluid meshing. That we already done the meshing. We've taken it, will showcase, but at the moment I'm going to consider the local mesh, and near to the surfaces how it should mesh. So I'm going to consider these faces. So near to these faces, the mesh should be appropriate. Remember, this mesh will take some time to mesh it, and even the results extraction might be slower due to the fine mesh and the system performance. If you have the better system, you can run it within a short span of time. So I'll set it to level 3 of the requirements, and okay, no issues. You need to have a better experience on the meshing side if you want to deal with this kind of advanced meshing. And this is about the fluid mesh automatic. I had already configured it before, don't need to worry about it. So once you're done with this, you can just create mesh. It will take some amount of time to mesh it. Once it is done, you're gonna just see the mesh, how refined it is. Every time, each and every one, 90% of the people use the automated mesh level 7. That is not going to help you more to get the more refined answers, remember that. Yeah, so if you want to preview the mesh, you can use the results drop down. From there you can just preview the mesh. This is the global mesh and this is the local mesh which we had applied. From here you'll get the normal one. So if you want to preview the what exactly the mesh we had done for the model and the fluid, you can use the results drop down mesh. You can use the cut plot as well, or you also can use the mesh plot as well, no issues. So you can just use show option. This will show you the advanced mesh refinement at the curved regions. Can you see how refined it is? If you want to refine even more, you can do it, but it is time consuming, remember that. So this is how you can just deal with the advanced meshing. Very important thing. Can you see at the corners and the curvatures we needed the fine refinement so that it should have the better results at that regions that we have extracted. Yeah, this is about meshing. Once the mesh is done, you don't need to remesh, just run the analysis, you'll get the results. So just to preview the results, we can just activate the cut float. I had already created it. So this is the mesh float. We already seen it. Just to preview, you can see, and now I'll showcase the cut float. So this is the one. I'll hide the mesh float and you could see this is the velocity float. You can edit this. You can change it to pressure float or whatever float you are looking for, and just use the I symbol to just preview the same thing. You can see the streamlines, how exactly it has oriented. Yeah, this is about the surface float. You can simply just click on green check and you are using the pressure float for this, and this is how the pressure float looks like. Now the ISO float, you can simply edit this and you can take the reference as velocity, preview, appearance as pressure, transparency level 0.5, and once you click on show, you will get the preview. With respect to 80 kilometers per hour, this is the ISO surface plot. This is how it's gonna look like. And finally, to deal with the flow trajectories, you can activate the rectangular pointers 200 and you can simply click on green check to preview the same. If you want, you can even select the surfaces to have the better flow or trajectories on the particular surface. That is again quite advanced, but I'm looking for the flow over the model. This is how it is. So if you want to deal with the fine flow on the nearer surfaces, I told you just need to select the surfaces where exactly you're concentrating the flow distribution. According to that, you'll get the flow trajectories. Okay, finally, to deal with the coals, you can edit the coal plot, and I'm looking for the drag force in the CD. Just click on show to get the same thing. So you could see the drag force is 456, or maximum is 457, 460 approximately. So this is what the results with respect to case studies and reference papers I got it, and when I run the analysis, even I got the same thing. So CL value might differ depending upon the calculation, as we are dealing with the manual calculations. They will slightly vary, remember that. Okay, and this is how you can just deal with the SolidWorks CFD, that is external flow analysis, to deal with this kind of analysis. Yep, that's all about the session. I hope you got the clear-cut idea about the CFD analysis, that is external flow analysis on the vehicles. If you have any doubts or if you are looking for any kind of trainings, you can reach me anytime. You could see my number, and if you are new to this particular channel, please do subscribe and just even share this particular YouTube link to your friends and colleagues so that we can develop more and more contents for you guys. Yep, that's all. Thank you guys. Stay tuned. Bye everyone.